E equals mc squared is probably the world's most famous equation. This equation has the power to transcend the barriers of culture and languages. Many people think of this equation once Albert Einstein's name is mentioned. Although many are familiar with the formula, very few people know what it means. He came up with this concept in 1905. Prior to this time, entities such as time, space, mass, and energy were concepts that were thought of as separate aspects of the universe as a whole. But by bringing these seemingly unrelated elements together, Einstein completed his theory of special relativity. In E equals mc squared, Einstein concluded that mass and kinetic energy are equal to one another since the speed of light is constant. In other words, mass can be changed into energy, and energy can be changed into mass. Mass changing into energy is demonstrated by the production of nuclear energy. Particles are smashed together and their energy is captured. Now, going from energy to mass requires a process referred to as particle acceleration. During this process, low-mass particles speed through an instrument that causes them to collide and form larger particles. Here's a graphical representation of a kind of particle accelerator. Now, this is interesting. The mass of an atom is generally not going to be equal to the sum of the individual masses of all of the atomic components, such as the protons, the neutrons, and the electrons. Mathematically speaking, the mass of the atom would be slightly smaller than the total mass of all of those subatomic particles if you put them together. There is one exception, and that is the hydrogen isotope with an atomic mass of 1. All it has for subatomic particles is 1 proton and 1 electron. But for all other atoms, the loss in mass is going to be exactly equal to the amount of energy that was released. This is what Einstein identified in his equation E equals mc squared. Energy equals change in mass times the velocity of light squared. The calculated gain of energy that's equivalent to the loss of mass is actually called the binding energy of the atom because it's binding all those subatomic particles. Because as the subatomic particles are binding, that energy is emitted. Mass is in kilograms, and the velocity of light is in meters per second, but don't forget we have to square it. So technically, the units are meters squared per second squared. Those are the base units, and together they form the derived unit, the joule. A more useful unit of energy for nuclear reactions is the mega electron volt, which is written as MeV. Mathematically, it looks like this, which we could boil down to look like this.